Welcome to the reconnaissance section. Hi, this is Gary, and this lecture is about scanning. So reconnaissance is the first part of a penetration test. It's a French term which was taken over by the military, and it basically means that you want to get to know something. So we are going to try to collect as much information about our target as possible. We are going to scan the target to see which ports are open, and then we are going to try to identify the running services. All the information we collect might be useful at some point of the exploitation. So basically, in our case, reconnaissance really means getting to know our target, collecting information, and by that, discovering the attack surface. As I said, this lecture is about scanning. I always say that I'm not a huge fan of scanners, but when I say that, I mean that I don't like when people rely only on the results of a vulnerability scanner. Scanners are very useful tools when they are used properly. And this is the right moment to turn to scanners. I'm pretty sure that you have already heard the name of Nmap. I think this is the single most famous scanner around the world, especially since Trinity used it in the movie Matrix. If you haven't heard about Nmap, I will give you a quick overview. It's mainly a port scanner to scan TCP and UDP ports and try to identify what service could run on the open ports and what operating system could be running on the target machine. Knowing the open ports is important to us because those are the services that we can attack. So basically, the open ports and the services running on them is going to be our attack surface. Alright, so this was already too much slides and too little terminal. So let's get to our Kali Linux. Alright, so let's start a terminal. And if you type nmap, then you will get the help of the tool Nmap. So as you can see, there are quite a lot of configuration options for Nmap. We are not going to try all of them because that would take forever, and to be honest with you, I never use all of these configurations. So let's start. In a normal pen test, you are in a network. The first thing you want to do is discover the network and see which IPs are actually running machines. So to do that, you want to do a ping sweep. That will basically send a ping message to each IP in the network to see whether it answers to that ping. Beware that you can configure any computer to ignore ping. They won't be discovered by a ping sweep. But we will see that there are other techniques to discover those machines. But even just those which are going to answer are a good starting point. But of course, don't start scanning the internet because there are just too many machines. So first, I will check our IP. So you see, this is my IP address, and this is the net mask, which is typical to this network domain. So I want to scan this whole network to see which IPs in this network are actual machines. If we scroll back a little bit to the top, there is a host discovery part, and here it says ping scan. Disable port scan, which means that we will only do a ping scan and we are not actually going to scan the ports. We will do that later. Alright, so nmap -sn for a ping scan, and I take my IP and I tell that 24 network, it's because the network part of the address is 24 bits because the last 8 bits will identify the machine. So I want to test all IPs defined by these 8 bits in this network. Alright, so let's start this. So as you can see, I get back a bunch of answers. By that you will actually see the things I have in my network. In your case, that's going to be different because you will see the things you have in your network. Now, in a normal assessment, when the whole network is in your scope, then you would note all these IPs and you would test all these IPs during the assessment. Since we are going to focus on our virtual network, I will focus on the machine. And as you remember, we noted the IP of that machine, which is this one. And it says Alice. That was also in the slide of the network. So this is Alice's computer. And of course, I don't want to test our TV at the moment. I will ping that IP just to make sure that it really does work. And as you can see, we are receiving the ping responses back, which tells us that this machine is running. So now we got to the point when we can scan this specific IP, and let's start with the basic, which is basically Nmap and then the IP address. Now this is very simple, and it also doesn't tell us too much because this basic scan is only going to scan the first 1,000. Right now we're scanning TCP ports. We will talk about UDP later. And I mean, unless you're scanning a big network and to speed up the process, you don't want to scan all ports, I don't think it makes sense to scan only the first 1,000 ports. So I will want to scan all 65,000 of them. Also, if you want to scan multiple machines at the same time, there are various ways. I will print the help again. So there are various ways how you can define which network you want to scan. Here, Nmap gives us a couple of examples. You can use the host name. You can use the IP address. You can say how we set it, that host name or IP / the network size, or so you can say IP and then those numbers which you want to scan. Then you can define the from to for that specific number. So you can see third one will be from 0 to 255, and the last one will be from 1 to 254. But again, at this moment, we are only going to scan this one machine, so I won't bother with specifying networks. So it's time to start fine-tuning our scan. So if you look at the help again, there is a part which says scan techniques. What we're going to use is a Tcp Syn Scan. I think that's the most useful. However, I recommend you to look through these various kind of scans and Google them, because some of them are really interesting from a technical point of view. Some of them are pretty deprecated and not really used anymore. That's why I'm going to focus on the Tcp Syn Scan. So let's do that. All right, so let's open a terminal. And the tool we want to use is Nmap. If you can just execute it this way, you will immediately get the help page, which lists all the various parameters for Nmap, which we mostly not going to use, because at this point we don't really have to tune our scans as much as these parameters would provide. So if you are in an unknown network, you can start with a ping sweep. That will basically send a ping message to each IP in the network to see whether it answers to ping or not. Beware that you can configure any computer to ignore pings, so these computers will not be discovered by the ping sweep. There are other methods to do that, but even those which will reply are a good starting point for an assessment. But of course, don't start scanning the internet. So first I will check my IP address to figure out in which network I am. And you can see this is my IP address, so I'm in a standard network, and this is my expected net mask. And to define a network in Nmap, you can use various forms. Some of them are listed here. So you can use the host name, you can use host name / the network segment, you can use IP address, you can use IP address, but in specific parts exactly define which numbers are allowed, etc. So I will do Nmap, and again, if you look at here at the host discovery, there is a option called ping scan, disable port scan. So it says we're only going to send pings, but we are not going to scan the ports, which we will do later. So I will do -SN and then the IP address, and I tell that I want to scan the whole 24 network, which basically says that the first 24 bits of the IP address define the network, and the last 8 bits are going to define the host in that network. Okay, so let's do that. As you can see, there are a few hits. When this is a full-scale pen test, all of these IPs would be in your scope and you would test them all. However, in this case, we are going to focus on this specific machine because this is our Windows 10 machine. Remember, we noted the IP address and it also says it's Alice's machine. So that's what we are going to scan in this lecture because I don't want to waste your time with scanning my TV. So the next step is to find out which TCP ports are open on this particular machine. So I will do Nmap and IP address. That's the simplest thing you can do. This has already have some hits, but you need to know that when you scan like this, it only scans the first 1,000 ports, which could be useful when you're scanning a big network and you don't want to slow you down by scanning the whole 65,000 ports. But otherwise, if you're just scanning one machine, then you can scan all ports out there. I will print the help again. And if you scroll here, we have a couple of scan techniques. Since we are still on our first date with this machine, we want to be nice and gentle to it. So I will just use a simple Tcp Syn Scan. This means that Nmap will send a SYN packet to the machine, and depending on how the machine responds, whether it's an ACK or a reset or a lack of response, and depending on how the machine responds with an ACK or reset or with nothing, then Nmap will decide whether this port is open or not. This is basically the TCP handshake. If you don't know exactly how the TCP handshake works, I recommend you to Google it because that's a pretty basic networking protocol. Also, as I said, we want to scan more than the first 1,000 ports, and as you can see, you can do that with the -p, and here are a couple of examples. So you can say a specific port, you can say from 1 till 65,535, so basically that's all TCP ports. Or what we are going to use is Nmap -ss, which is the Syn Scan, and -p minus. This dash here means that we want to test all ports on the target machine, and then I will add the IP here. Alright, this is going to take a little bit longer, but it's not going to be terrible. Alright, much better. It took some time, but we got quite a few open ports. However, the Syn Scan only tells us whether a port is open or not. And even though it sometimes says which service it is, like HTTP, that is just a bad guess based on the port number and which service should run on that port. So for instance, port 80 is usually dedicated for a web server, so HTTP. Or port 22 is usually dedicated for SSH server. At this point, however, we don't really know whether this is really a web server or whether this is a Pando pub, whatever that is. It's just a guess from Nmap who tries to figure out which service that is, but it doesn't really prove anything at this point. Since right now we are not worried about being discovered by a blue team, for instance, we can use more aggressive settings like -a, which includes OS fingerprinting and execution of Nmap scripts. Nmap scripts are basically small scripts which will scan the specific port to try to figure out what kind of service is exactly running on that port. There are a library of Nmap scripts included with Nmap, but you can also extend it yourself. Alright, so I will do Nmap -a for, let's say, aggressive minus P minus to scan all ports, and then the IP. All right, let's see that. By the way, if you want to know the status of your scan, you can just hit key like space, and then it will tell you that we are at 2%, and it might be around 6 minutes. This is not necessarily very precise. All right, it finally finished. And as you can see, we got much more details to the results. So let's quickly go through a couple of things. As you can see, Nmap did now a much better job on identifying the services because it was part of the aggressive scan. So here, for instance, it can say that this is an Apache HTTPD with precise version number, which OpenSSL, Python version, PHP, etc. For instance, here, this is a SMB port. It can tell that this is a Windows 10 enterprise evaluation, etc. And even can tell that this is in the Evil Corp domain. All right, the TCP Fingerprint is something that you can submit if you know the exact version of the operating system. You can go here and submit it and tell which one it was. By that, you will enhance Nmap. And then here also a bunch of data that was extracted by the scripts, and you can see that it can tell us the computer name, the domain, the fully qualified domain name, etc., etc., etc. So you could see that this already gave us much more information. So at this point, you will probably want to note all this information you collected. You can make Nmap store the results in various formats. This is the standard, but you can get it in an XML or in Bash. And many tools can import Nmap scan results, or for instance in Metasploit, you can even start Nmap from Metasploit, and that will automatically save the results in its database. But we'll talk about Metasploit later. So at this point, we only know half of the story because we only scanned TCP ports. The problem is that scanning UDP is much less fun. The reason is that TCP protocol is pretty nice because it's gonna answer to you whatever happens. Or if the port is open, then it's gonna answer to you because there is this thing called the TCP handshake. So if you send a SYN request and there is a open port, then even before starting to talk to the service, the TCP handshake must be done, so you will see whether this port is actually open or not. However, UDP doesn't reply. So you can just send UDP packets to port, and if the service running on that UDP port doesn't understand what you're saying, it's just not going to reply to you. And because of that, you will never know that there is actually a service running on that UDP port. Nmap still supports UDP testing, but it is much less reliable and it takes much more time. And it's kind of a black magic. Right now, I will only run the first 1,000 ports, and you can scale it up in your mind to see how much time it would take to scan all 65,000 ports. All right, so it is Nmap minus V to get some more information. That stands for verbose. And SU is to specify a UDP scan. And then I tell that I want the ports from 1 to 1000. And then the IP address. And let's get on with it. So we get this information because we specified -v to be more verbose. Alright, so it's finally finished. As you could see, it ran for ages, and we just scanned the first 1,000 ports. So it's significantly less than what the whole port range would do. So it took 1047 seconds for me. That's around 17 minutes. So you can guess how much it would take to scan the whole port range. It found a couple of services. As I said, this doesn't mean that these are the only services. And generally, there are really interesting services running on UDP, so you should always do UDP scan too. However, just make sure that you run it during the night or just to make sure that you can let it run for some time. All right, let's recap what we did in this lecture. So we learned how to use Nmap to find running machines in the network, then do a port scan on these machines, both TCP and UDP. So you should note all this information what you're collected so far, because they are going to be useful in later lectures.